Hey everybody, Harold here. Today's video I want to talk about basic data types and casting in polars. So back here in our Colab notebook, I want to import polars as PL and from rich import print for my pretty printing. Um, Basic data types are, you've seen them if you're familiar with other programs, like int64 is all positive and negative integers to a certain range. Uint means unsigned, so only positive integers. Floats are like 3.14 pi, something with a decimal in it. Strings, word, Boolean, true, false, date, time, and duration. Categorical. Uh, I'm going to explain that in its own video, but it is one of the basic data types. Uh, Python, when you load a data frame, it implicitly infers data types, like up here. I didn't tell the schema to do this, and so it inferred the dates as strings because it couldn't tell. It got the F64 right on price and the I64 right on customer ID. I would have to write a schema or cast to make these dates dates. Python implicitly infers data types. You can declare them explicitly using a schema. So I'm not going to make you write all this. It's in the notebook. Import polars and daytime, and time delta. This PL config set table columns 20 ensures that I see all the columns across. It doesn't scrunch them up when we display it. I'm going to run this cell. It's got signed integer, unsigned integer, a float, string, is UTF encoded 8, not PL.string, a Boolean, a date time, a duration, and a categorical. So that's my schema. Now I'm going to create a data frame, and at the bottom, the last argument is schema equals schema. So I'm just creating columns of all these different types of data, signed and unsigned integers, floats, strings, bool, dates, datetime, duration, and categorical. I'm going to print the data frame and the type. So signed integer, I64, I have 1, -5, and 10. Unsigned, those are fine, 1, 5, and 10. Float, the decimal number. String is a words. Bool is either true or false. Date column is date. Date time is date time. Duration is a duration, US time, a day, an hour, minutes. Categorical is cat, ABA. I'll do a whole video on that. Here's my D types down here at the bottom. If something isn't what you want it to be and you didn't infer it in the schema, you can cast. So I could say df equals pl.dataframe. A, these are strings, 1, 2, 3, and B, these are also strings. First 3 days in January. Those are strings. I could have put infer a schema and inferred it. Instead, I'm going to use with columns and change it. So df with columns, pl column A dot cast pl dot n64 and pl column B dot cast pl dot date. Should change that. So now they're I64 and date types. So using cast to change data types. I need to tell you about safe versus strict. Polars can either use strict and fail on invalid values, or use non-strict and it just turns an invalid value into nulls when you're casting. Create a small data frame 10, 20, oops, 30, all strings. Print df types. Raw numbers are all strings, including oops, because one of them is a string. It's inferred that's a string. They're all strings. If I say default strict is true, if I don't put any argument in there, whoops, invalid operation error. Conversion from string to I64 failed in column raw numbers for 1 out of 4 values, and the one it failed on was oop. So I say result equals df.withColumns pl.call raw numbers dot cast pl.n64 and add my strict equals false argument, and let's see what happens there. Raw numbers cast as I64. If the data type wasn't an integer, it threw a null in. So that is safe versus strict in casting. Strict fails on invalid values. Non-strict turns invalid values into nulls. So that's data types and casting in polars. Hope you liked this video. If you did, please like it and subscribe, and I'll see you next time. Thanks, everybody.